Hey everyone, my name is Dave. Welcome to the NTDRacing Speed Shop. Today we'll be working on this RZR 200 EFI to get a new roll cage put on it. So we're ready to race this thing. And why do we need a new roll cage? Well, we're going to try to race in the Mint 400 with my little boy in the 200 EFI. And to comply with the regulations for the Mint 400 or most of the racing organizations, you cannot use the stock roll cage on side by side, so you need to replace those, which means you either need to go purchase one and have somebody put one of those on, and I realize those are expensive and often a barrier for people to get their kids into racing, and we want more people racing these things with us. So what I'm going to do is I'm going to go step by step and I'm going to show you how I go through the entire process to make one of these roll cages. And if you want to follow along and you're starting at zero and you want to build one of these, then you can do that. And at the end, you're going to have some really cool tools like maybe a tube bender and also a welder and those kinds of things, and especially the bendtech software. And maybe you're a small company that's looking to start building roll cages for RZRs at large. What I hope to show you is the versatility of the bendtech software, especially being used if you have a Dragon A250 or a Dragon A400, and you can see how easy it would be to go into mass production of things like this for your own shop. Let's go ahead and get started with part one of this series, which is going to be removing the roll cage off of this one, some of the body panels, using some basic tools to get some really precise dimensions off the roll cage so that we can prepare to put that into the bendtech software. Part two, we'll be taking all those dimensions and making pick points and also building a roll cage in the bendtech software, and then also calibrating some of our tooling in the shop to be used on the bendtech software. Finally, part three, we're going to go ahead and cut these tubes out on the Dragon A250 and start welding them together. And then part four will be a cleanup where we'll show you how we do all the safety things inside the vehicle such that it is compliant with all the race regulations that we'll need when we go to the Mint 400. Hopefully all those things sound entertaining and useful to you. You'll consider subscribing, but right now let's go ahead and start disassembling this RZR 200 EFI. All right, let's take a quick look at the plan for the disassembly of this 200 EFI. We're going to go ahead and get the doors off. We're going to start getting some of the plastic panels off, the whole bed off, and those kinds of things. And then we'll disconnect, which is basically 6 locations where the roll cage appears to me to be connected to the chassis with just some Torx bolts right here. And then under here, I'm assuming it's the same kind of connection that you see right here, which is going to take some of those like 3/8 or some kind of a metric bolt to get those off. We should be able at that point get the roll cage off, level this thing out, and then start taking dimensions. Let's go ahead and get to that. All right, let's take one quick pause to show you how I got here. I removed the doors. It was just a really simple Torx bolts that kind of go on right here and right here. Right now the seatbelt's on. It's going to stay on this side. That side of the seatbelt will have to come off because we got to put a 5-point belt in over there. And besides that, the other plastic parts kind of came out. You kind of see how I had these little fasteners here I had to take out. What I basically did is I took 2 screwdrivers, I put them underneath both sides of the tabs, and I lifted up on both sides at the same time. And I don't think I damaged those, and I'll be able to use those again as I go for putting these things mostly back together. But right now you can kind of see that to get this roll cage off, there's a Torx bolt here. There's 2 larger bolts here with some Allen head screws, a ton of mud from my dude who went raging out in the mud and didn't clean it anyway. And then some more bolts up here, and this roll cage should come right off pretty easily, and then we can start doing some measurements. All right, I want to show you where we're at with the build here and some decision points. So first off, you can kind of see where the old roll cage kind of came off, and it has these kind of bungs down here. And I have added these on, and these will be the welding termination points for the new roll cage. These will be in the description below if you're looking to purchase those for your own build. And then this is kind of what they look like when you get them. Anyways, just a little contrast. You see this piece right here is there, and as I go over to the other side, this piece over here is taken off. You can kind of see some of the structure down here. So what we're dealing with and where I came up with the rules and what I'm going to make, how I'm going to make the roll cage is basically loosely based off of this. This is Unlimited Off-Road Racing's rule book, and this is how they want this roll cage to look. Now, it doesn't have to look exactly like this, but if it doesn't look exactly like this, you kind of need to be able to justify why you change the design. And it talks about the tube thickness. They want it 1.25. I'm basically going with 1.5 inch all the way around just because I have the dies for that and all that kind of stuff. And it just won't add that much weight, but I do think it'll add more strength to the design. So as I kind of go back over here, and here's the part I want to kind of talk about, is this part right here where you have this tube coming across next to your left elbow. You have what I would call it basically your A pillar here, and let's just call this your B pillar. Is this tube comes down and it splits off right here. And my plan is to maybe make this a little bit different just because of the way this whole thing is put together. Is I will have the tube going for your next to your elbow going all the way across from end to end there. And then the real question is how do I tie it in down here to the frame? Now what they have the picture showing is it comes down over to here somewhere and ties into the frame, and then it comes down over to here and also ties into the frame, which I just don't like the way that that's going to go together. The tubes are smaller than I want to use, and I'm not a big fan of the design. And so I'm going to change it a little bit. What I'm going to do is I'm going to run a plate from here. I'm going to weld it into this bottom tube. And this will be really some of the only welding that I'm doing into the roll cage. And the plate's going to come straight up. Right here, it's going to rosette weld once or twice into this tube also. So it's mainly tied into this tube, but it'll tie these two tubes together. Which, nice part about this tube, it also has a member that goes all the way across underneath the seat here, giving it a little bit more strength. It'll come up, it'll go above this panel right here, and then it'll have a connection point, have another, basically two plates that'll come together, and then another tube that'll go across laterally. It won't be very long, but it'll give me a place to have basically the A pillar come down, connect to that tube, and then back over to here. And what that gives us is a nice triangle to add some strength. So, when you're building these things, some of the failure modes that I'm thinking about are obviously any kind of like frontal, like come to a full stop, rapidly kind of impact, where a good containment seat and good seat belts and those kinds of things and seatbelt connection are going to be key for that. Number two would be any kind of rolling, or you're upside down, you're basically challenging the top of your roll cage, and that's where having that A pillar come down and into there will resist any kind of crushing of your roll cage. And the second would be like a side impact, where they basically have a collision with another car from the side trying to push everything in. And I think that by having those plates tied in here, you might get some bending, but you won't get the full failure of parts of the vehicle into the legs of the driver, which is one of my other main concerns there. So from there, we'll have this connection point right here for the roll cage. And the other one we'll have to make is this one back here also. We're going to put a tube all the way across here so we have a connection point in the back. And once we have all of the landing points for the roll cage, now we can go in and get really accurate dimensions so that we can make those into pick points and put those into bendtech. With that, let's go ahead and hop on to Fusion 360, and I'm going to use my Langmuir Systems Crossfire XR over here to cut out some of those pieces. All right, so let's get to the nerdy CAD part of this thing real quick. If you ever watch my videos, I do this a lot. I'm going to go through one bracket really quick, and you can go back to a lot of my videos and see how I do this. If you are not using Fusion 360 and a plasma table, it's going to take a lot longer. It's going to be done with an angle grinder, but I think it'll take a lot longer. And it's a worthy investment, especially if you're a fabricator. I'm going to select front. I'm also going to select sketch, and I'm going to sketch on that front plane, which is the X and Y plane. I set hotkey G to be my center rectangle, and that's going to be 3.5 inches by 5.5 inches is how big this plate is going to be that I'm going to put on there. So I'm going to weld across this bottom piece, but I'm going to make a line. So I'm hitting the hotkey L. I'm hitting X, which is going to turn on. Hotkey X means I'm hitting X on my keyboard, which makes these construction lines. I'm going to draw a line straight up, and that's going to be 3.5 inches. That's where that second bar is going to land. It's 3.5 inches center to center on those two tubes. And then I'm going to hit a hotkey L again, and I'm going to just draw a line across here. And I'm going to say that is 2 inches there. And then I'm going to click this thing called a constraint. I'm going to select that. I'm going to select the center thing, and now it's going to center that line on those two things, on this center line right here. And then when I turn off construction lines, hit hotkey C, and I make holes about 0.4 inches for my rosette weld. Hotkey C, and that's where those are going to go. I'm going to hit my hotkey L again, and again I'm going to hit the X for construction lines, because construction lines are lines that it won't cut when it's cutting on there, and then all the other lines it will make a tool path for. So 0.75 inches is down how far down I want those holes to be, and then I'm going to hit hotkey L again, and those are going to be 2 inches from center to center. So hit 2 and enter, and then again I'm going to hit this constraint on that line on the center. And then just since I'm going to turn off construction lines by hitting the X, I'm hitting the C to get a circle to come up, center circle. And for a 3/8 inch bolt, I like to use a 0.42 inch hole. It's a little bit oversized, but allows you to kind of have a little bit of wiggle room as you weld stuff and stuff moves around. But it doesn't get too big when you make that hole that it kind of becomes a factor as far as strength goes. I think 0.42 there, and there's the hole, and that's pretty much the whole panel that I'm going to have. I'm going to go ahead, and since the top of this thing is not going to be welded, and I would just like to have it kind of softened a little bit, I'm going to put some fillets. Is that what you call these? I don't know. I'm going to make these so that I can make that nice and smooth inside there, and then there is my part. I'm going to hit the hotkey E or the E key on the keyboard. I'm going to select my part, then I'm going to extrude, and I'm going to make this a 0.125 for 1/8 inch plate steel, and there's my part, and it is ready to go into the plasma cutter. And you see how quickly I can make that, and then we just throw it in the plasma cutter, which is already ready to go. And I made my bracket really quick, which is, you can do this obviously with an angle grinder all day long and a drill press and all that, but it just, I think, goes a lot faster using a little bit of CAD. I'm going to go ahead and make the other brackets I need to make. We'll make it like in 2,000 times speed. All right, so more parts are off the 200 EFI. Let me show you where we're at. We just got these brackets down here on the side. You can kind of see how, like I said, they rosette weld into here, and then it just kind of tiggles all the way across there. I think that's a good place mounting location where the tubes will come down and engage that 1.5 inch tube. And then in the back we have this tube also, which engages to the original frame location for the razor, and then the 1.5 inch tubes will also kind of come back here. I'm not sure what you would call those. Those would be maybe the C pillar or something like that, but just like the braces that kind of come off the back of the roll cage. So now what we need to do is we need to take the dimensions off this thing, and it needs to be accurate. And I kind of had some thoughts on how to do it. I could have taken the old roll cage and on the floor mapped it out and got X, Y, and Z coordinates. But since we've kind of added these pieces on, it's going to be a little bit more complicated than that. So I need to build something and kind of have some way to accurately get the dimensions off of this thing. And there's really only 8 different locations I need to get to start with the pick points for the design of this roll cage. So it's going to be a little excessive, but I have all this lumber here, which I will be building something you'll see here in a second. And then I also have some pieces of angle aluminum. And I get this stuff from Home Depot. It costs about 15, 18 bucks. I have 3 pieces 1 inch angle aluminum. And I'll show you how all that goes together. The last part of this, before we get started, is I did level the vehicle. So I got some of these scissor jacks underneath here, and that's just to get everything nice and level such that at least in the Z axis, these two should be zeroed out from each other. And since this thing it's really well made, and I find that, you know, as far as the machining of it goes, I got a feeling that these will also be zero in relation to each other as far as the Z or the up and down axis. So that should make it a little bit easier to make this cage, because in theory it should be symmetric on each side, but not necessarily. We're going to find that out once we put this thing together. Let's go ahead and get this measuring device I'm going to make put together. One of the first things I'll be making with this is what I'm going to be calling, I guess, the Y-axis. And I'm basically making a straight edge with something I can use to index to 90 degrees. And I'm just going to hold this thing together with just a few simple rivets to maintain that 90-degree piece. And then I'll show you, once I got it all together, what I'm going to use this thing for. All right, I would call this a pretty critical stopping point, so I can kind of show you what I'm doing. This is where you're calibrating everything before you take measurements, and probably the most tedious part. So the first thing is the razor is totally leveled left and right, and mostly leveled forward and out, but not quite as important. This right here, this bar, I'm calling this my X-axis. That is completely level, and it is also the exact same distance from this bung right here. I'll get back to that. This right here is also completely level and the exact same height as the X-axis over here. This piece of angle that you saw me make on my bench over there is my Y-axis, and that's going to help me take the distance. This will be my X, this will be my Y, and then this one, almost identical, just shorter, is going to be my Z-axis. So the first thing I had to do is make sure that this line, which is my X, was exactly the same distance on both sides for the bungs, just to make sure it was to make it easier for the taking measurements. So what I would do is I'd move this thing back and move the X back and forth until it's right over top of the bung. And I use this piece of metal here to set it to where I was right over top of the leading edge of that bung. I'd make a mark right here where I'm going to be using all the time for measuring my Y-axis, and then I would move it over all the way over to the other side. I'd measure the same place in the bung, and as long as those two lines lined up, then that thing was aligned with the basically parallel with the machine. So when I go back and I want to take my X, Y, and Z values, I'm going to line up the X left and right until it's over top of that bung. I'm going to line up the Y until it's over top of the bung. You see I'm kind of aiming for this little dot right here, which is the center of the bung, because remember, bendtech takes the center of the tubes. And then I'll drop this one down, and I have actually a point which I'll be using. And where that point falls on there, then what I will do is, again, I will mark it, the piece of metal right there. I'm going to mark the Y-axis right there, and I'm going to mark the X-axis right there. And then this will be my starting point and my 0 point. So this should be 0, 0, 0, my origin. When I move this thing over to the other bung and I take the measurements, now, since I've aligned this whole thing, then that measurement should sound like X equals about 35 left, Y is 0, and Z is 0. And then likewise, when I come over and measure this bung, it should tell me something like X is maybe -2 because I've actually moved outside the vehicle. Y is about 40, and Z is maybe up or down an inch or something like that. And those will be the coordinates that I have to take based off of these. Let's go ahead and start taking some measurements and make them as accurate as we possibly can. I usually will take them twice to make sure that I get them exactly right. And if I don't get it right, if they don't equal each other after 2 measurements, I'll go back doing a 3rd or 4th time until I can get them absolutely precise. Okay, I'm going to try to talk through this while I'm doing it so you can kind of see. It's a little bit tedious, but there's 8 points, and it takes maybe an hour to get the whole thing if you just kind of go back and do it a couple times to make sure you got the measurements correctly. But here's how I am doing this with the setup that I've got, and there might be an easier one out there. The first part that I need to get is, I think the most difficult measurement is this X-axis first, or the left and right, which will go into to bendtech. And the reason is because you've got to get this piece right here absolutely level to make sure that you have the X in the right place. So basically what I did is I set the Y up there and just lets that kind of slide back and forth. I bring this Z axis, or the up and down, or I think they call it the ceiling and floor on bendtech. And I'm going to basically bring that tip down, and I'm going to set the tip right on the center where I want it. And then what I'm going to do is I'm going to come over and look at the level and see that the level is not right. Well, it tells me I need to bring the level to the driver's side as I'm seeing it. And I'm going to slide the slider over, and once it's level, at that point, I'm just going to go ahead and hold the X axis in place and remove this whole thing. I'm going to set this down. And then I'm going to come over to the X axis, and I'm just going to lock it in because this is the right place for this thing to be. So I got these little clips. I'm going to clip this on here, and this will keep the X axis from moving. And actually what I can do is now I can take my pencil and I can go ahead and mark on here where the X axis fell in relation to the piece of metal here. So I marked that on there, and I've done this a couple times, and I just put that line in the exact same place that the line is overlapping itself that I did before. So it's telling me that it is a repeatable process, and that my measurements, as I kind of go back and forth, should be about the same. I'll bring back up my Y and Z, or my front and back and ceiling and floor axes here. And then now I'm going to do is I'm going to roll this one back over that point, make sure everything looks aligned to me. And then I'm going to go ahead and take that pencil again, and I'm going to mark on this piece of metal. This is going to be my Y right there, or my front and back. And then now I can take this one, make sure that it's exactly in the right place without putting weight and basically loading up. Basically don't want to pull this piece of metal down because it could be off by 1/8 of an inch or something like that if I do that. So I want it to be exactly right. And then now I can take this one and I can mark it right here. And again, it is right on top of the line I wrote before. So I went ahead and on this line I wrote a 0. That's my 0 point. On this line, again, I wrote the right superimposed on top of each other. I wrote a 0 and a 0 on that one. And then now this is my 0 point. This is going to be my origin for all of my other pick points. So now we're going to go ahead and let's move it and do this back one. And I'll show you how now I take those dimensions. So I'm going to take these clips off of my X axis because those will be different now. I'll bring it over to about where I think that X axis is going to be, trying to take out any kind of movement, because this thing, is so far out there, it will move back and forth just a little bit. And then I'll take my front and back, or my Y. I'll take my up and down, or my X, and I'm going to put that tip again right on the center of the piece I'm trying to measure the pick point for. And then now, my front and back is perfect. My X is perfect. I just need to work on, my Z is perfect. I just need to work on this X axis. So I'll keep moving this one until it is right. That bubble is 0 on my level there. Move this. This is the tedious part, I think. Getting the X in the exact right place, I think, is the most difficult part of this whole process, using this technique that I'm using. Now, there are machines out there I know that will allow you to just basically touch the point and pull a point off and all that. I got a feeling they're thousands of dollars though. And this was about 50, and all the stuff I can use again. So I got my X set up right there. Again, I'm going to come over with my clamps. I'm going to go ahead and clamp this thing down. I'm going to mark where now this is going to be what I would call the B pillar. So I could write on here B, so I remember what line is what on my X axis, or my left and right. I'll come back over here with these two things. I'm going to set this thing up. Put again the tip of the Z right on top of that point. That's all there. This thing squares itself up. I'm going to mark that line off, and I'm going to come over here, and I'll take this and I'll mark this line off. And if you can see it, that's the line right there, and it's the exact same line that I did before. And again, that line's the exact same line I did before. And so, I think as you're taking measurements and you want to accuracy and precision, I think this is actually working pretty good because, again, I'm so close that it's less than the thickness of this 0.07 pencil or whatever. That's how close the accuracy or the repeatability of this thing is. And then as I look on the x-axis, it's the same thing. It's maybe off on this one by, it looks like about 1/8 of an inch, which, you know, I like to be a little bit closer than 1/8 of an inch. A 1/16 seems pretty good because if you, as you think about it, as you're TIG welding something, if it's a 1/16 of an inch off, you're probably gonna do okay. And then what I'll do now as I start to transfer these onto a piece of paper is I will now measure from my 0 point to that new point. So in this case, the x-axis, and whenever I measure something like this, I usually will start at the 10 and then I will measure it out. And so in this case, it goes from the 10 to the 13. So that's exactly 3 inches. And I don't usually like to start at the very end of the tape measure because this piece moves, but depending on if you're pushing against something or you're pulling against something with a tape measure. So if you start with a 10, I find it to be a lot more accurate. So that'll be that. So in this case, is that pick point will be 3 degrees left. And then I would measure from my 0 point, again, putting my 10 over here at the starting point to the end. And that's going to be, it says 50 3/4, so 40 3/4, because you subtract the 10. So it is going to be back 40 3/4. And then in this case, just because I've done this a few times now, is I look at this piece right here, the difference between this one and this one, it required me to push the x-axis or the up and down, or ceiling and floor they call it, down about 1/3 of an inch. So it'll be down 1/3 of an inch. And then that will be my pick point, 0, 0, 0. And then this one will be all those values I just said. We'll go ahead now and get all the rest of the pick points. But I think the thing I'm trying to get across here is that you have to find a way to be very precise in getting your measurements, whether you're taking it off of a chassis that already exists or you're building your own chassis. And I do have a video for that, and I'll try to put a link here or in the description below for that. So like I said, the tricky part here is that bendtech will not provide you dimensions for stuff. That is something you need to get yourself before you unlock the power of their software and their hardware. So in the next video, what we'll do is we'll take all those coordinates that we just pulled off of this side-by-side, and we're going to drop it into the bendtech software, and we're going to build in their software a full roll cage for this. And then the payout will be using the Dragon A250 to cut the tubes and then fabricate the roll cage for this RZR 200 EFI. And hopefully what you see is that you could do this at your own shop. You could build something like this, and it just really doesn't cost that much if you're willing to do the work. And then also, because of the versatility of the bendtech software and hardware, it is definitely scalable, where you could go into full production using one of the Dragon machines, making roll cages for side-by-sides or Jeeps or any other kind of race vehicle or something like that. Hopefully you find value in this video and you'll consider hitting that subscribe button, and we'll see you next week. Take care of yourself.